Okay, so this is the 1.2 quiz for the algebra periodic tomorrow. I'm going to start with question 1. Consider the following functions, blah, blah, blah. You don't need to know this. What functions are even? Now, I have a trick for you guys with even functions. If it's an absolute value alone, I'm talking alone in the absolute value. Like you can have 5 absolute value of x. It's fine. It's even. But if you have an absolute value x with something else, like x minus 2, or x plus 1, x plus 3, x minus 5, whatever, it's not even. Okay? If you have also check the degrees and polynomials. For example, this is a polynomial. This is a polynomial. Like first, if you have x squared plus 4x to the power of 4, check the degrees. If they're both even, then they are. It's an even function. Okay. Now, you might have forgotten this, you probably did, but if you have a constant, so like 5 plus 3x squared, the degree of this constant is 0. So this is even, okay? And I'm talking constants only. If you have 3x, for example, this is 3x to the power of 1. So this is an odd degree. So as you can see here, though, this is a constant. So this is 5 to the power of 0. Or not to the power of, I can't say 5 to the power of 0 because that would be 1. 5 to the, and its degree is 0. 3x squared, that's to the second degree, يعني. 0 and 2 are both even, so this is an even function. But if you were to have, let's take the 3x example, 3x plus 4 x squared. This function would be neither even or odd, because you have an odd function, you have an odd degree here and you have an even degree here, they cancel out. So that's some notes for even and odd functions. Now we can apply them here. Okay, so 5 root x, 5 to the absolute value of x and the absolute value of x. Obviously, these are by the notes. You can't use 5 at the absolute value of x plus 1 because I said this doesn't work. Let me just check. I'm recording. I'm scared I'm not. Okay. 1 to the 1 over x. Let's try eliminating ones we definitely know aren't even. So this is not even. This is we'll leave this for later. This is definitely not even because this has a degree of 1. Ignore this, that has a degree of 0. So this is not even. This has a third degree, so this is not even. Now to check if it's an even function for this one, for example, f of x has to be equal to f of negative x. Okay, so f of x is 1 over x. F of negative x is 1. We'll just put as this is f of x, and f of negative x is gonna be 1 over negative x. So as you can see, these two aren't the same, so they are not equal. So this is not even. Just write not e. Okay. Question 2. Select the graphs that represent one-to-one functions. This is not a one-to-one function because if you draw the horizontal line test, you see that this is not even because it passes 2 points right straight away. We don't need to check the other conditions. Do the same for all other graphs. You see this passes 2 points here, this passes 2 points here. This does not pass 2 points because if you draw a horizontal line test everywhere, you're not going to find 2 points that intersect. This passes 2 points here, this passes 2 points, this doesn't pass anywhere. So these are one-to-one functions. Number 3. Okay, in each box represent, select the letter that represent. Okay, whatever. D. This is a function. Listen, they're testing here if you know your relations and your functions, and if they're one-to-one or many-to-one. If they're a function, I'll just write f equals vertical line test, VTT, for example. And if it's 1-to-1 equals horizontal line test, so HTT, let's just say. Okay, vertical line test. This passes the vertical line test, so we know it's a function. So it's either going to be C or D. Now, you do the horizontal line test. You see here it passes 2 points. So this is a many-to-one function, it's not one-to-one. So your answer is going to be D. Now, this one, it fails the vertical line test because as you can see here, you have 2 points. So this is a relation. Now, you do the horizontal line test to find if it's one-to-one. As you can see, it also fails that because 2 points here, for example, 3 actually. So that's gone. So that's a many to one relation, which is B. And C is a function because vertical line test. And if you do the horizontal line test, you're going to see that it only passes 1 point. So this is a one-to-one function. Okay. Question 4. One-to-one. I just explained that I'm not going to do it. I can just do the horizontal line test. Okay. Y equals g of x equals 3x cubed minus 2. Test to see if it's an odd function. Okay. G of x equals 3 of x. Okay. So g of negative x is gonna be 3 negative x cubed minus 2. Okay. So now you're gonna want g negative g of x. That does not look like a g. I am so sorry. Equals negative your function. So whatever. Just distribute the negative sign. You're gonna see it's negative 3x cubed minus 2. Okay, so now this is positive. So this isn't an odd function because we had positive 3 negative x cubed, and then negative negative g of x we had negative 3 positive x cubed. So it's not an odd function. Now, in the options, I also believe it said it's not an even function. It's an even function. This should be common sense. It's obviously not going to be an even function, but if you wanted to try it, you could try it. I'm not going to try it too. Okay. Select the steps to consider the function, blah blah blah. Pick the steps that could be used to prove that f of x is a function, is an odd function. Okay. So obviously you're gonna want to start with f of negative x equals to negative f of x. Sorry, f of negative x equals to negative f of x. That's to test if it's an odd function or not, right? Okay, and now you wanna substitute. You wanna try f of negative x first. Did they check for a negative f? No, they did not. Okay, so we're only gonna test for f of negative x. F of negative x is equal to negative 5x minus 4 over x. Now, over minus negative x, sorry. The negative with the negative here cancel out to make a positive. So this is your final answer. But here they also included this step. This is the multiplication step, which I skipped. But yeah, those are your 3 options. Okay. Question 7. Consider the function p defined by the rule y equals p of x equal x squared to x plus 2 squared to the power of 4. Okay. You want to try. You got p of 3 and p of negative 3 here. Now, p of 3 and p of negative 3 are not equal, so it's not an even function now. Remember, an even function, I explained it, f of x equals to f of negative x. So it's not an even function. They're not going to ask you to test it for odd or not, so just to skip an odd function, put down not an even function. Okay, which of the following are even functions? Again, here you want to do the test the degree and the absolute values. So this is going to be to the power of 0. So this is even, so this is an even function. Like that was the biggest tick I ever did. Absolute value of x plus 3. That's going to be correct because absolute value of x is alone. X to the power of 4, that's an even degree. That's an even degree here. So this is going to be correct. Now, x plus 1, this is not going to satisfy it. 4x plus 1, this is going to have a degree of 1, so it's not correct. This one, you are gonna have to test it yourself. So let's test it. Okay, so this is gonna be negative 2x minus 1 squared. Now immediately you can tell this isn't gonna be correct. Factor out the negative. So negative 2x plus 1 squared. Let me just draw this in a better way. You want to factor out the minus, so minus 2x minus plus 1. Okay. As you can see here, our function is 2x minus 1 squared So I forgot the square. Here it's negative 2x plus 1 squared. So it's not the same function. It's not an even function. Okay, 9. Restrict the domain. Sorry, one second. Okay, I'm back. Did I do question 8? Yes, I did. Okay, question 9. Consider the graph of G of 1 and B0. Okay, you want to check because you want to do the horizontal line test. Now this is going to fail it because you're going to pass multiple points. Everything between here, this area, and this area is going to pass it. Because if you do the horizontal line test, it's going to be correct. It's going to be 1-to-1. Here it'll fail because it's going to pass all through many points. So you want to test the point. So this is going to be -3 and this is going to be 4. So negative, you put the smaller value, x has to be greater than the smaller value. So -3 and the smaller than the bigger value, which is 4. Okay. So that's question 9. Question 10 now. How many questions are left? Oh my god. I got this one wrong. Let's see why. Oh yeah, this one was probably a misclick. Okay, g of x equals 5x cubed, which the following statements are true. Obviously, it's a set of all real numbers. G of -x equals 5 times -x cubed. That's correct. It's an odd function. It's an odd function that you test yourself, but since they gave us g of -x, you looked for it. So it's going to be -5x cubed for a negative g of x. And g of -x is also going to be -5x cubed, because here you multiply this becomes -5x cubed. So these are equal, so it's odd, just like O. And now we have the g is an odd function. We answered that question by solving. Yeah, okay. G of -x, because g of g of x, we just solved, we just checked for that again, so that's correct. Okay, consider the function g of x equals x squared plus 4x. G of x is not an even function, yes, because here this degree is 1. So it's not even. G of x is defined as the set of all real numbers. A key that's defined as the set, because we have no condition. We don't have it as a denominator in a fraction. We don't have it in a radical. Okay. Here you're going to have to follow the quadratic general form, which is y equals a x minus h squared plus or minus b. This doesn't really matter. Plus b, let's just say. Okay. Now to satisfy, so to restrict the function to make it 1-to-1, x has to be greater than or equal to h, or x is less than or equal to h. Okay, so now they want x is greater than or equal to k. K is h. K is going to be 6. Now, something you have to know. They might trick you and put h as +5. This is wrong, because in the form it's -h. So if they gave you +5, x is gonna be greater than or equal to or less than or equal to -5. Basically, easy way to memorize. Put the opposite sign. Here you have -6. You want to put +6 here. Don't write the positive sign. Just put 6. If you have a positive sign here, put the negative sign. So that's how you memorize that. It's fairly easy. Okay. Question 13. The graph of a function g is shown in the diagram below. G is 1-to-1 for all functions. X is less than or equal to k. What's the largest value of k? This is basically what I just did, but this is graphically. H is the vertex or the turning point, so this maximum point. Now you don't look at the y-axis, ignore that. I made that mistake in class, so you're gonna want to look at the x-axis. Your x-axis is gonna be at 0. So x is gonna be less than or equal to k, or greater than or equal to k. Okay, and k is 0. My god, my bad. Okay. Apply the horizontal line test. This is easy. I'm not going to skip that. And that's section 1.2. I'm going to do 1.1 now. I think just